We're the Avengers, and this is our scooter safety senior design final. My name is Noah Johnson, and our team consisted of Brandon Tao, Eric Chavez, Alan Prieto, Javis Quach, and myself. I would like to take a moment and have a brief introduction of what these scooters are and why we're referencing them, why we chose to do scooter safety, and what we actually did to these scooters to accomplish our goal. These scooters that we're referencing are actually the scooters that we see around downtown. These are a new form of transportation, which are provided by companies like Lime, Lyft, and Bird. We chose to do this as our senior design project because there's a recent spike in accidents according to these scooters. Last August, there was a death of a man named Cameron Hagan. Any accident on these scooters is tragic, and as engineers, this is actually what we're trying to prevent. With any new form of technology or any new form of transportation, there's going to be new problems that arise that we have to tackle, and that's what we're trying to do. Essentially, what we actually did this semester to solve this goal is we added various technologies on the scooter that would warn the user of possible dangers or collisions that are approaching the scooter. The first technology we added were the ultrasonic sensors. We have two ultrasonic sensors mounted on our scooter. We have one that measures things coming from the back right and one that measures objects coming from the back left. If an object were to be coming in close proximity on the back right, the right handlebar would vibrate, alerting the user that something is close to his back right corner. Likewise, if an object were coming from the back left, the left handlebar would vibrate, alerting the user that something is coming from the left side. The next thing we added to our scooters was a Lidar and a relay. The Lidar measures 5 meters out, and the goal was if an object came within 5 meters of the scooter, the relay would shut off the motor to stop the scooter from colliding into the object. Here's a brief video showing this in action.
Let's go. 3, 2, 1. You're gonna zoom in on his thing when you try to grab it? Oh yeah, alright.
As you can see, when Eric gets about 5 meters out from the wall, the relay cuts the power to the motor and the scooter stops. It's kind of hard to see in the video when exactly the power to the motor is cut. So to demonstrate this, at the end of the video, Eric revs the power, the throttle to the scooter to show that it's still not moving, indicating that the Lidar did in fact cut the power. The next thing we added to the scooter was a servo motor. On top of cutting the power, there's still a lot of momentum going in the scooter after going a high speed. To solve this problem, we wanted to add a servo motor that would actually physically pull the brake to cut down on the stopping time of the scooter. Here's a short video showing the servo motor working. As you can see, the servo motor successfully was able to pull the brake in completion. If the scooter were traveling in motion, the scooter would have come to a complete stop much faster than previously with just the relay cutting the power to the motor. The next thing we added to our scooter was a power converter. This was a convenience so that we could power our Arduino, which is the brains of our project, directly from the power of the scooter so that we wouldn't have to have any sort of external power supply. Here's a video showing the scooter turning on and successfully converting the power down to 5 volts, which the Arduino will run on. As you can see, when the scooter is powered on, you can briefly see the power converter displaying a higher voltage than 5 volts. That's because initially the power from the scooter is 20 voltage. That is what the scooter needs to run. However, the Arduino runs off of 5 volts. So we have to drop this down to 5 volts, which is seen successful in this video. That's all we got done this semester. Unfortunately, we weren't able to fully complete our project due to the recent COVID lockdown. Ideally, if the semester were to go on like this, we would have included the servo working in tandem with the LiDAR and tidied up the scooter to produce a final project. Here's a picture of all our group members, and we just wanted to say thank you to our professors, to faculty, and everyone who helped us. Thank you.